Hi, this is Engineer Wild speaking. In this video, we are going to take an overview about stray current in DC traction system. Also, stray current consequences. Note, since a stray current could affect mechanical or civil components, so this video is made simplified for non-electrical specialists to understand the stray current. Before we start, let us take a simple example to understand the flow of current in electricity. Suppose that we have battery, which acts as a source of power, and we have a light bulb, which acts like a load. So, we need to connect them by two wires. One is connected with the positive side of the battery and the bulb. Another wire is connected with the negative side of the battery and the bulb. Now here, we will have flow of current from the positive side of the battery going to the bulb, then coming out from the negative side of the bulb, going back to its source. And it should go back to its source. Easy, huh? Okay. Now let's move on and apply what we saw in the last example on the DC traction system. Instead of the battery, let's replace it with a DC electric substation, which acts as a source of power. And replace the bulb with a DC train that acts as a load. Here, instead of the two wire, we will have the positive to positive connection is made possible by an overhead catenary conductor, while the negative connection is connected with the railway track. As before, the flow of current will be going out from the positive through the conductor that's going into the train, then coming out of the train to the rail and coming back to its source, which is the DC substation. But this is ideally. In practical, we shall have a layer of concrete and a layer of soil. So step by step, let's take the flow of current. Going out from the DC substation with no changing, going through the train via overhead conductor, then coming out of the train, and at certain point or points, major part of the current will go back to its source through the track railway, and a minor part relatively will leak inside the concrete and soil, coming back then to its source. This leaked current called a stray current. Now, in case if there is a steel pipeline underneath the railway, the stray current will flow through the pipeline due to the low resistivity of the steel, going back to its source via the steel pipeline. And at the point where the current leaves the pipeline, it will go under electrochemical reaction, resulting in initiating corrosion in that part. So, corrosion process of steel or metals that are nearby DC railway could be accelerated more than in regular site.